Welcome to the lesson on Introduction to Motion. We are able to define motion, analyze motion along a straight line, identify uniform and non-uniform motion, calculate speed and average speed, define velocity, calculate velocity of a moving object, define acceleration, calculate acceleration of a moving object.
Tired. I'm not able to understand anything about motion.
Don't worry, Tina. I will explain to you everything about motion. In our everyday life, we see a lot of motions around us, like moving car, flying birds, galloping horse, and flowing river. These are all examples of various motions. Motion is a change of position. It can be described in terms of the distance moved or change in its position with respect to the surrounding or time. Moon makes the motion around the Earth in its orbit. All the planets move around the Sun in their fixed orbits. Location of an object. We need to know a reference point. For example, our house is located 2 kilometers from the railway station. Here, railway station is a reference point. Hence, to describe the position of an object, we need to specify a reference point called the origin. Suppose you walk from the railway station to our house. Then you have covered a distance of 2 kilometers.
Yes, that is right.
But are you actually 2 kilometers away from the railway station? What is the shortest distance of our house from the railway station?
I am not sure what the shortest distance is, but it can be less than 2 kilometers.
Yes, it is called displacement. Displacement is the shortest distance measured from initial to the final position of an object. The path of the motion of an object can be curved or along a straight line. The simplest type of motion is the motion along a straight line. Let AC be a straight line path. Let Ravi start on his bicycle from point A. He crosses a candy shop at B. He reaches point C. And then he realizes that he should buy some candies. He returns back from point C to point B. What is the distance covered?
Total distance covered by Ravi is 90 meters.
The numerical value of a physical quantity is its magnitude. What is the displacement here?
Displacement is the shortest distance measured from initial to the final position of an object. Here, initial position is A, final position is B. Hence, displacement is 30 meters.
You are correct, Tina. In this case, magnitude of displacement is 30 meters. Therefore, the magnitude of distance and displacement is not the same.
Dad, can displacement be 0?
Yes, why not? If Ravi rides his bicycle from A to C and back to A from C, then displacement of Ravi will be 0.
Are all motions same or different?
All motions are not the same. Some motions are uniform and some motions are non-uniform. In uniform motion, object covers equal distances in equal intervals of time. In non-uniform motion, an object covers unequal distance in equal intervals of time. For example, when a car is moving in a crowded area, in certain equal intervals, unequal distances are covered.
Then how do we measure the rate of motion?
We can measure rate of motion of an object by finding out the speed.
Speed? How to find this?
Speed is distance travelled by an object in unit time. The SI unit of speed is meter per second. To specify the speed of an object, we require only its magnitude.
But Dad, how to find rate of motion for non-uniform motion?
We find average speed of an object for such motion. The average speed of an object is obtained by dividing the total distance travelled by the total time taken. If an object travels a distance s in time t, then its speed v is given by s upon t.
Can you explain it to me through an example?
Mr. Sengupta drives his car 100 meters in 20 seconds and then another 80 meters in 10 seconds. What is the average speed of his car? Here, total distance travelled by the car is equal to 100 meters plus 80 meters, which is equal to 180 meters. Total time taken is 20 seconds plus 10 seconds, which is equal to 30 seconds. Average speed is equal to 180 meters upon 30 seconds, which is equal to 6 meters per second. Any object like a car or any vehicle moves in any direction. Then direction of motion can be specified with its speed. Actually, the quantity which specifies both speed and direction is known as velocity. Velocity is the speed of an object moving in a definite direction, and it depends on speed and direction both.
But Dad, how do we express the magnitude of velocity if the object is moving at variable speed?
We use term called average velocity to express it. It is given by the arithmetic mean of initial velocity and final velocity for a given period of time. Mathematically, average velocity is equal to u plus v upon 2, where u is the initial velocity and v is the final velocity of the object. Speed and velocity have the same unit, that is, meter per second. During uniform motion of an object along a straight line, the velocity remains constant with time. In this case, the change in velocity of the object for any time interval is 0.
What about non-uniform motion?
In non-uniform motion, velocity varies with time. It has different values at different instants and at different points of the path. Thus, the change in velocity of the object during any time interval is not 0. Hence, we use acceleration. Acceleration is a measure of the change in the velocity of an object per unit time. If the velocity of an object changes from an initial value u to the final value v in time t, the acceleration a is v minus u upon t. The SI unit of acceleration is m upon s square. The acceleration is positive if it is in the direction of velocity. An object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time. Then the acceleration of the object is said to be uniform. The motion of a freely falling body is an example of uniformly accelerated motion. If the velocity changes at a non-uniform rate, then the object is said to have non-uniform acceleration. For example, if a car traveling along a straight road increases its speed by unequal amounts in equal intervals of time,